Alright, welcome to the lesson on inverse functions. First thing we need to know is what an inverse is. So it's simply taking an equation and solving it for the other variable and then flipping the variable. So we have inverse functions. On a graph, if you were to graph both of the original function and the inverse function, they would be a mirror image over each other over that diagonal y equals x. So in a relation, you guys dealt with relations in algebra. It's just a set of ordered pairs or a set of coordinates that have a special relation to each other. So for a relation to be an inverse, all you have to do is take the x and the y variables and switch their places. So if you look here at a and b, all the difference is that the x and the y have flip-flopped. So all the ordered pairs are just the opposites. So in example 1, we're going to try that. So all we're doing is switching the x's and the y's. So this bracket here is just showed as a set. That's what that means. It's a set of ordered pairs. So we're going to take negative 8, 6, and we're going to flip the x and the y. So it becomes 6, negative 8. And then the next one, oh, that was bad. Sorry. 6 and negative 8. And then the next one would become negative 2 and 6. And then the last one would be negative 3 and 7. So we close it with that bracket. And that's it. So that is just taking a relation and finding the inverse of the relation. So inverse functions. So we have that f of x again, that function notation. So when we find the inverse of the function, what we're going to have is this f to the negative 1 of x. So this just represents an inverse function. Okay, it's not a negative 1 power or anything like that. So steps to find an inverse function. Step 1 is to just think about that f of x being a y. You can physically write it down on the paper or just think about it in your head. Second step is to solve for x. Third step is to then switch the x's and the y's only, not anything that's with them attached to them. You just take the x and the y and change them. And then the last thing is we write it in inverse function notation with that negative 1 power. So example 2, so finding the inverse of each function. So remember, we're going to think about that as being a y. So you can think about just this as a y. Or you can write it down like I said. So if we have that, now we can go ahead and do step 2. We have solving for x. So we need to get x by itself. So add 1 over and then divide by 3. So you're going to have y plus 1 divided by 3 equals x. And then that third step is to just flip x and y. Now, the second and the third step are kind of interchangeable. Depends on what you want to do. You could flip the x and the y to start, and then you would be solving for y. You'll see it both ways in math textbooks, and other teachers may teach it that way as well. So it's good to see both. So now we have this. So this flipping the x and the y. So now this just becomes x plus 1 over 3 equals y. And then that last step, changing the y to the f inverse sign. So we have that down there. So I'm just going to write the x plus 1 over 3. So now this and the original are inverses of each other. So if you were to graph 3x minus 1 and then graph x plus 1 over 3, you would see their mirror images. And I might show you that on a graph here in a little bit. So next one. So remember, replace this with the y, either in your head or on paper. I'm going to do it in my head this time. So now we're just going to go ahead and solve for this x here. So the first thing we would have to do is multiply by 3. So now I have 3y equals x minus 8. And then we just add the 8. So now we have 3y plus 8 equals x. And then we're taking just the x and just the y and flipping them. So now we're going to have 3x plus 8 equals y. And that would be our inverse function. We're going to write that down here, 3x plus 8. Okay, now I'll go ahead and pause the video and try this checkpoint on your own. All right, welcome back, and let's go get to solving. So first thing we're going to do is solve for x. So subtract 1. So now we have y minus 1 equals a negative 2/5 x. So remember, when we have a fraction out front, we want to get rid of it. You can do a couple steps by first like multiplying by 5, and then you would divide by negative 2, or you just multiply by the reciprocal. So I'm going to multiply both sides by 5/2. So negative 5/2. So we get negative 5/2 times the entire left-hand side. So we have to put that left side in parentheses. Equals x. Now we can flip the x and the y. So now we have this. And when I go to write it down here, I'm just going to go ahead and distribute this negative 5/2 into both of these terms here. So we get negative 5/2 x, and then negative 5/2 times negative 1, that would be a plus 5/2. And that's it. All right, moving on. So we have example 3. So I can find inverses of a linear function using a graph. So this is kind of what I was talking about before. So we have 2x plus 4. So we can graph that function because it says we have to graph both functions. So let's go ahead and graph this. So this is in slope-intercept form, y equals mx plus b. Now remember that this 2 is the slope and this 4 is the y-intercept. So I'm going to go ahead and plot the y-intercept there. So y-intercept is 4. Actually, let me get better data here. So we know we're running through here. And then slope of 2. So slope of 2, we would go down 2 over 1, down 2 over 1, continue on until we reach the edge of the graph. So we'd be somewhere probably around here, and then over up to, so somewhere right here. And now if I can take a line and draw it, so I'm just going to use this dotted line here. So here's my function. Okay, that's the original. And now we can go back and we can look at finding the inverse. So we're going to do exactly what we did before. So 2x plus 4. So we need to subtract the 4 over and then divide by 2. So we're going to get y minus 4 all over 2 equals x. And then we're going to flip the x and the y. So x minus 4 over 2 equals y. And now to get it in slope-intercept form, the y equals mx plus b, we just want to split these up into two terms. So we have 1/2 x. So we're going to divide both top terms by 2. So 1/2 x minus 4 divided by 2 be negative 2. So now we can go ahead and graph this on the graph. So we have a -2 as our y-intercept, so we can plug a -2 here. And then slope is 1/2, so it means we're going up 1 and then over 2. Up 1 over 2, up 1 over 2. And then go this way, we have to go down 1 over 2. Down 1 over 2, down 1 over 2, so somewhere over here. So now if I graph that, so from here to here, we can see what I was talking about before. We can see that they are mirror images of each other. If you folded one of these over this x, this y equals x line, they're perfectly symmetrical over that line. Okay, and then the next one, I'm going to approach this a little bit differently. So we have that. -2 is the y-intercept, and we have a 1/3 slope. So up 1 over 3, up 1 over 3, and then down 1 over 3. So there's that. So go ahead and draw that line. Actually, before I do that, I'm going to go back. So we're looking at these points. So this is a different way to graph inverse functions. All right. So we can take the symmetrical. We know that we are 2 away this way, and we can go here. So if we look, those 2 points right here are mirror images of each other. And let me change the color real quick so we can kind of see that. So the blue dot and the red dot are right across that line from. And then we go to this one. We go 1, 2, 3 up, and then we can go. Let's see, where we're the over here. Okay. So notice the coordinates, just like in the relation. So this coordinate here is a 3, -1, and then this coordinate is going to be a -1, 3. So all we're doing is flipping the x and the y. So we have this coordinate down here. We have a -3, -3. So if we flip those, we're just going to get the same point. So both the red and the blue dot are right there on the y equals x line. So now if we graph these, and we know we can really graph a line if we have two coordinates. So I have that, and then so something like that, and the original. So now we have a mirror image over each other. Of course, you can do what I did in part A and just walk through this and solve for x, flip the x and the y, and then you would have your function. Then you could graph it that way. So either way works. So go ahead and try your checkpoint here. So which of the following points lie on the graph of the inverse? Okay, so we have an original function here. I do not want that line. We have an original function, 5x plus 18. Okay, so on a multiple choice question like this, you're given a bunch of different coordinates here. We need to see what would work. So remember, these are inverses. So what we're going to have to do is we're going to have to think about this in our head, the opposite here. So I need to make sure to see if this -2, 8 would work in this function here. So if I were to plug this in, -2 in here into the x, does it become 8? Is the output 8? So -2 times 5, we know is -10, plus 18. Well, That's 8. So that works. So A, we just got lucky that it was the first one. And that if it wasn't, you just keep running through these and plug these in to see what actually works. But the key is knowing that we're looking for the inverse of the given function. Okay, so we need to know that we have to flip the x's and the y's. Okay, it's a common SAT problem that you'll see. All right, and then the last example here is so verifying an inverse using composition. So function composition, what we learned a few days ago, we need to apply to this problem. So what this says right here, f of g of x equals x. Mouse is messing up. F of g of x, so here's function composition. If that ends up equaling x, and g of f equals x, so they both have to equal x to be an inverse of each other. Okay, so two functions f and g are inverse functions if and only if these two things are true. So what we're going to do in example 4 is we're going to do f of g of x and g of f of x and see if they both equal x. So remember, g goes inside of f, so we're going to take that function and we're going to replace x in f. So we have 2x, so we're going to write that g function now. So 1/2 x minus 4, and then don't forget the plus 8. And now we're going to simplify this. So distribute the 2 in. 2 times 1/2 is 1, so we get a 1x there. 2 times negative 4 is negative 8. And then plus 8, which we know just is 0, so we end up with x. So far so good. So now we need to do the opposite, g of f of x. So now f goes inside of g. So 1/2 x, and our x is f function minus 4, and now simplify. So 1/2 times 2x is just x. 1/2 times 8 is a positive 4 minus 4 and x. So the answer to this question would be yes, they are inverses of each other because these two things equal x. And then part B, do the same thing. G goes inside of f. Negative 4 times x over 4 minus 5 plus 5. So go ahead and distribute the negative 4 in. So negative 4 times 1/4 would just be negative 1, so we get a negative x here. Negative 4 times negative 5 is a positive 20. And that plus 5 drops down, and we end up with negative x plus 25. Well, before that step, we could already see that this was not going to be x. So if this one is not x, there's no point in doing the other one. We can just say that this is a no. They are not inverses of each other. Okay, so go ahead and pause, try the checkpoint, and we'll get to solving. All right, hopefully it went well. Let's see. We're going to do f of g of x first. So 1 over x, which is now our g function. So 1 over x minus 2, and then plus 2. Well, negative 2 and 2, that just cancels, and we get a 1 over 1 divided by x. Now we talked earlier this year, what do we do if we're dividing by a fraction? You also learned this in Algebra 1. If you're dividing by a fraction, all you have to do is take the reciprocal of the bottom and multiply it to the top. So we're going to get 1 times x over 1, which we know is just x. Okay, so that one checks out. Now we have to do the next one, g of f of x. So now we have 1 over 1 divided by x plus 2. And then minus 2. So the same thing, we have 1 divided by a fraction. So remember, all we have to do is take the bottom fraction and flip it and multiply it to the top. So if we flip this and multiply it to the top, we end up with x plus 2. And then that minus 2, that would cancel each other out, and we're left with just x. So the answer to this question would be yes, they are inverses of each other. Okay, that concludes our lesson.